Lately, we've been talking about creating repeatable dynamic textures from scratch for the use of applying them to any generic piece of geometry that they would look good on. Wooden floors on the ground, circuitry on computer chips, and wool on scarves. Today I want to talk to you about another aspect of Substance Designer, where you can tailor custom procedural textures to a specific piece of geometry. This makes it easy to integrate a tool into your pipeline, much like the one that we're going to create today. Let's imagine you have to create a digital shelf of pots as part of an ad for a plant shop. The client asks you to create something that has a little bit of wear and tear to show that these pots last a lifetime, but they don't want them all to look the same because that's a dead giveaway for 3D renders. What's more is that they provided you a specific 3D model of the item that they sell. Oh, and they said they want it done by the end of today. We don't have much time, so let's get started. Okay, so the first thing I wanted to do is show you the UVs, or the UV process that I'm using here in this example. I'm using this app called Rizom UV, and it's my go-to when it comes to UV everything, whether it's making seams or packing, or even when it comes to unwrapping things and distributing them even on multiple tiles for a UDIM workflow or something like that. So it just kind of has everything in one place, and this is what it looks like. So I've got my flower pot geometry here. In this case, it's a very simple model, and it's so simple it doesn't even have a bottom, and it doesn't fill in the middle. But this is just kind of like what I wanted to use as an example. So I have my UVs laid out like this. It's one cut, and it all fits in this one singular UV tile. And you can see that I can tell where the inside of the pot is here, where the numbers are seemingly going upside down, and it goes out through and down this way. And so to make it really easy to visualize in Substance Designer in the 2D view in this square grid, I've done it this way, and I've just kind of flattened it out like this. And now I know that this is the inside of the pot. This area here are the ledges of the pot, and then the outside of the pot is down here. Okay, so now we're in Substance Designer, and let's make our new graph. So we're starting off with the PBR Metallic Roughness template, and let's change the graph name here to Procedural Pot. And I'm going to set this to absolute, and we're just going to stick with 2K to make it simple, and 16 bits per channel. And let's hit OK. Okay, so the first thing I like to do is create this final blend, and this hooks up a lot of what we're going to do with our height information into the normal ambient occlusion and height outputs. So let's start with that. I'm going to hit spacebar and add a blend, and then I'm going to hook up this blend to the normal conversion node, and then down where the ambient occlusion map is, I'm going to remove the uniform color and hit spacebar and type in ambient and get this ambient occlusion generator and hook this up to the ambient occlusion map. And then I can hook this final blend into the input of that. And then on the height, I'm going to remove that uniform color and connect the output of our final blend into the height. And that is our final blend. So I'm going to right click and comment that just so we can keep track of it and call it final blend. So now that our graph is set up, let's import our 3D mesh. And by import, I mean link. So to link the mesh, I'm going to click on the package here in my Explorer window, and I'm going to right click and go to link and choose 3D mesh. So I've got my mesh OBJ here. I'm going to click on it and open. So you notice that nothing happens here, and that's because we have to go to our resources folder here, which is just created, and there's our pot geometry. I'm going to left click and drag and drop it into the 3D viewport. And now here is our pot in Substance Designer. So now to get the specific information from this geometry, we need to bake our mesh maps. So to do that, I'm going to go to the geometry here, right click on it, and choose Bake Model Information. So this is the Baker panel, and it has a lot of interesting values and buttons and properties. But the most important thing is that we have our 2D view here where we can see our baked mesh maps, and we can select what kind of maps we want to create. So to figure out what maps we want to bake, we're going to go down to the bottom left here where it says Baker's Render List, and we're going to choose Add Baker. And so these are what Substance Designer can create from our mesh. Let's choose a couple now. The first one I'm going to pick is the ambient occlusion map from mesh. Now, for all three of these that we're going to make sure that you choose the one that has map from mesh on the end. So ambient occlusion map from mesh. We're also going to get the curvature map from mesh. And finally, we're going to get the bent normals map from mesh. So now we have our three maps here that we're going to create in this list. And there's one more thing that we have to do, and that is check the box that says use low as high definition. And this is because Substance Designer also allows you to select a high resolution mesh, one that has a lot more geometry and tessellation. Maybe you created it in ZBrush and you added some details there, and you want to bake those into these maps. You can do that. But because we don't have that, we're just going to use our low resolution version here. So we've ticked that box, and now I'm going to choose Start Render here at the bottom. And now Substance Designer uses your GPU to quickly bake through these meshes and create our maps for us. So now that that's done, I'm going to hit Close. And in our resources, we now have 3 new maps that we can use, all generated from this specific piece of geometry that we imported and linked into Substance Designer. To finish our setup here, I'm going to drag in these mesh maps into our graph. So let's make some room. And the first thing I'm going to start off with is the curvature map. So I'm going to drag that one in here. And then I'm just going to make a comment by right-clicking and saying curvature. Then I'm going to drag my normals, do the same thing and make a comment. This specifically is bent normals. And then finally, I'm going to drag in the ambient occlusion. Great, so far your graph should look like this. Okay, so the first bit of detail that we're going to add is some edge wear here, some simple edge wear that's going to go along these specific edges on our mesh. So I'm going to make some room here. I'm going to drag these maps and just bring them all the way over here so we have a lot of room in the middle. And I'm going to go and branch off an output here from our curvature map. So I'm just going to select, left click and drag out, and I'm going to use a very cool tool called the Edge Dirt node. So after double clicking on the curvature map, you can see that this is where on our UVs, where the edges are in our plant pot here. So now if I double click on this Edge Dirt node, it's created this edge wear procedurally from that map. And as a helpful hint, you can see the Edge Dirt map has an input here called curvature. So now we can adjust some of these properties to further refine and specify what kind of edge breakup we'd like here. So to see what we're doing, I'm going to just sort of move this uniform color over here because we're going to use it later on. And I'm going to take the output from our edge dirt and just drag it into the input of our base color. And then to make this 3D mesh update with these outputs, I'm going to right click on my graph and choose View Outputs in 3D View. So now, along the rim of our pot, you can see we have our edge wear. Now, let's refine this a little bit more now that we can see what's in our 3D view. So I'm going to double click the Edge Dirt node. And for the level, you can see, if I bring it up or down, this is how much dirt and breakup we're getting. I'm going to choose something around 0.72. And then the contrast really refines this mask that we're making. I'm going to increase it to something like 0.68 is good. And then the variation breaks it up even more so. 0.42 is good for me here. So now if we rotate around the mesh, you can see we got some variation here on where this small breakup around the edges are. So because I know that this can be color information eventually, I'm going to select my edge dirt, hit spacebar, and add a gradient map. And this just is an easy way to convert this grayscale information into color data. And then if you'd like to add some further control to this after the gradient map, I'm going to add an HSL node that stands for hue, saturation, and lightness. And so eventually, if you change this hue value, you can change the color of the edge wear. And now, because I want to get back that gray base color that we had from before, I'm going to blend this on top. So I'm going to zoom out, I'm going to find that uniform color that we dragged over, and I'm going to create a blend. I'm going to set this blend to add, and then in the background, I'm going to have my uniform color, and then I'm going to add on this edge wear, so we get something like this. And now, if I connect this to our base color output, There we go. We've got our original color and our edgeware. So now it's time to create even more edgeware, and we're going to create some larger details. So I'm going to organize this a little bit by moving these nodes and selecting them, hitting spacebar, and I'm going to frame them up. I'm going to call this frame Micro Edgeware. To add some further detail, I'm going to branch off another connection from our curvature and let go. This time, I'm going to add a shadows node. And the shadows node is really cool. And what it does is it takes a grayscale input and treats it like height data, and then simulates adding a light at whatever angle you specify to create this shadow. So if you see, I increase the shadow distance, and then in the 2D view, we're getting more of that simulated shadow effect here. And I can change the light angle, so it simulates the light coming from a different point in space. And for this particular effect, I'm going to go for something that comes up from the bottom. So I'm going to hold shift while I change the light angle to snap it here to 270. And now we have something that looks like this. If I zoom in a little bit, you can see the edge softness and sample slider. I'm going to crank the samples all the way up to 16. And I'm just going to adjust this edge softness. So if I bring this all the way down, you can see that the edges look a bit more sharp and they're more settled underneath these lines. And if I extend it out over to the right, it kind of pushes the shadow up in the direction that the light is shining through. 0.89 is good for the edge softness. And now that I look at it, I want to adjust my shadow distance a little bit. Let's change it to something like 0.41 is looking good there. So now based off of this curvature map from our 3D mesh, we have this shadow mask or map here. And what I want to do from that is add a slope blur. So I'm going to select my shadows node, hit spacebar, type in slope blur, and I'm going to drive this slope blur with a clouds to noise. And I'm going to keep the clouds to noise by default. And let's see what's going on here with this slope blur. I'm going to double click that. Let's give ourselves some room so we can see what's going on. And we're getting a little bit of an effect here, but that's because our slope blur has way too high of an intensity. So let's bring down the intensity to see what it is we're doing. There we go. We can adjust the samples here. I think I want something more along the lines of, here's good. So 7 for the samples. And as for the intensity, 1.4 looks good. So just to visualize what's happening here, I'm going to go to the slope blur, take that output, and plug it into the input of our base color. And now it sort of looks like we have these finger smudges from handling the pot by picking up from the edges. So let's blend the two things that we've done here together. First off, because I know that we need to be blending color data together, I'm going to add a gradient map here, and that puts that over here to convert it to color. And now let's get a blend. I'm going to set this to multiply, and I'm going to take the gradient map from our slope blur, put that in the foreground, and then take the blend from our micro edgeware here into the background. And now we can connect this blend to our base color. And here's what we have so far. I'm now going to take these nodes, frame them up, call them thumb smudges. So up next, I'm going to make a little bit more room here. I'm going to take all of these outputs and nodes except for the base color, and I'm just going to bring them down. And then I'm going to take these maps here, bring them down as well. And I want to connect this bent normals map up to the normal output here. So temporarily, I'm just going to bring this normal conversion node closer to our final blend and disconnect it here by deleting that connection. And then I'm just going to take the output of this baked map and put it into the normal output here. And you can see what that does. It kind of smooths out these planes here. So I'll reconnect the old one. You can see we've got sort of no plane changes here. They're very flat. And then if I reconnect the bent normals map, we've got a little bit more of a curve here, a little bit more shadow, and the bent normals are defining those planes a bit better. We're going to create some extra normal information later as we go along. So I want to add one more form of edge wear here. And up until this point, we've only been dealing with color information. We haven't done any height or normal information with this edge wear. So let's do that now. I'm going to branch off a third connection from our curvature map. And this time I'm going to use a histogram scan. So what I want to do is isolate these lines here in the curvature map with our histogram scan. So I'm going to find them first of all. So let's bring up the position. And then let's focus in on our histogram by bringing up the contrast. So I don't want to go too sharp here. So something around the lines of 0.71 is fine. So we've isolated those lines. And now to break them up, I'm going to add a slope blur. And I'm going to slope it with the same noise that we used before, the clouds too, just to keep things consistent. Put that into the slope input. Double click and see what we're doing. Again, it's a bit too much. So this time I'm going to crank the samples all the way up to 32 and bring down the intensity a little bit. Let's see what I'm looking for here. I'm going to go for a really subtle approach here. I'm thinking 0.04 so that we get these irregular line patterns here. And then because we're getting some of this grayscale information, I think I'm going to use a histogram scan to focus that in. So after the slope blur grayscale, I'm going to add histogram scan. And let's see, let's bring up the position to something like 0.56 and then dial up the contrast. So we went from these lines, slope blurred them, and then clean them up a bit. I'm just going to select these and frame them up. I'm going to call it edge wear height. So I'm going to leave this component here for now, but later on we're going to blend it onto another component that we're about to make shortly. So I'm going to make some more room, bring everything down, bring this down. So next up I want to add this cool little detail where it looks as if this pot was painted and then the coat of paint was a bit too thick and the drops of paint started oozing down and then hardened over time. So I'm going to click into my graph here and add a dirt 1 noise. Looks a bit like this. Now the reason why I chose this noise is because it's a bunch of small specks here, randomly placed, and we can use a histogram scan to isolate some of these specks and just get small sporadic dots that we can affect later on. So after the dirt 1, histogram scan, let's bring up the position. You can see we're just getting a few of those dots now. 0.36 is fine here. And then we'll bring up the contrast a little bit. And then after the histogram scan, I'm going to add another shadows node. So you might be able to see what I'm getting at here. Let's change the light angle to 270 and then increase the shadow distance all the way to 1. And so now I've got these streaks where they start off a bit intense and then as they go up they fade into white. A bit like rain droplets on a window or, in our case, paint. So in our shadows node, I'm going to keep the edge softness around 1, and I'm just going to crank the samples up to 16 so we get a bit more definition here. Now, after the shadows node, I'm going to add an invert grayscale, and I'd like to choose where on this pot I'd like these drips to be. So I'm going to click off into my graph, and I'm going to choose a gradient linear 1, which is a simple gradient going from black to white in a vertical fashion. I'm then going to add a histogram select node. So this is a good way to demonstrate what the histogram select does. In this gradient from black to white, as we change the position of the histogram select, we're choosing a part of that gradient, or in this case, the black to white values of our histogram, making it easy to select where on our texture we'd like to create this mask. So this sort of ties in as to why I've set up the UVs the way I have. And so I can increase the range that we're looking at and also increase the contrast to sharpen this particular mask. And so now I can widen the range and select which part of the position I'd like. And these are 3 really great parameters that you can then publish in this graph and then reuse depending on whichever mesh you're looking for, or then later on select where you'd like these paint drops to be at a later time. So let's utilize this new mask by creating a new blend. I'm going to set it to copy, and I'm going to take the drips that we have with this invert grayscale and put it into the foreground, and then I'm going to drag the histogram select and put it into the opacity input. So now if I double click here, this is where the mask is. Now it's going to be easier to visualize what we're doing if we connect this blend to the rest of our graph. So let's take the output of this new blend that we've created and connect it to the foreground of our final blend. So you're probably wondering where everything is. Well, because the top section of our UVs are the inside of our pot, we can see that these drips are now upside down and on the inside. So let's change some of our parameters so we can get this right. So I'm going to go back to the histogram select, and I'm going to change the position. And as I change the position, we're now changing where on the pot those drips are occurring. So I'm thinking I want to position right around here. Let's adjust the range a bit. So I'm going to bring down the position to something like 0.5, and then I can increase the range. 0.45 is good there. And the contrast is good for fading in this, but I think I just want to have it cut right to underneath this ledge of the pot here. So I'm going to keep things organized a bit here. Let's take these and put these on top and these on the bottom. And I'm just going to move these down a little. In addition to the drips, I also want to add a bit of dirt. And so we can reuse this dirt node. So I'm going to branch off another connection from the dirt node. And I'm going to invert it with an invert grayscale. I'm going to add a blend. And I'm going to use the output of this invert grayscale, and I'm going to put it into the foreground of the blend. And I want to use this blend mainly as an opacity control. So I'm just going to bring the opacity down. And this can be used to fade on this dirt as a published parameter. But I'm going to set it to something really, really low, like 0.03. And then I want to add this dirt onto my drips here. So let's make a new blend, set it to add. For the foreground, what I'm adding is this dirt, and what I'm adding it onto, the background, are the drops. And now I'm going to connect this new blend into the final blend, and we've got some dirt. Okay, so now we've added the dirt, but it's looking a bit busy and a bit messy. So let's use another one of our baked mesh maps to put our drips into the crevices of our plant pot. So the map we're going to use is this baked ambient occlusion map. And the ambient occlusion map is useful because it finds these crevices in the mesh, bakes them in, and allows you to target these specific areas. So out of the baked ambient occlusion map, I'm going to get a histogram select so that we can target these specific values. Let's adjust the position a bit to see what we're working with. So 0.8 looks good for the position. Let's dial in the range. And let's increase the contrast. So really what I'm looking for is creating this sort of slight gradient from where the rim of the pot is down to where the rest of the pot is. Then after this histogram select, I'm going to add a directional blur. So this directional blur will smooth out this noisy map. So if we go and we double click the histogram select, you can see we've got a lot of grain and noise here. This directional blur is going to smooth it out. But if I change the angle to something like -90 or 90, we can also blur this a little bit so we can get a smooth transition between what we're getting with our histogram select. So we get this all done with just one node. I'm going to change the intensity. Let's increase it to 14.3, looking pretty good. And then to use this as a mask, let's blend this on to the rest of our nodes here. So I'm just going to move this down. And let's find the last blend that we did. So before our final blend, we've got this blend, which is where we selected and added our drips and dirt. After this blend, let's add another blend. And I'm actually going to move, by shift clicking, I'm going to move this connection into the foreground. And then as the opacity of this blend, I'm going to use the mask we just created with that histogram select and directional blur. And you can see what it's done here. So if I disconnect that, we've got all of this information down here, and I reconnect it. it smooths it out a bit more and just adds it a bit more to the crevices. You can dial this in as you wish. So as an overview, we've created the drips, we added some dirt, and now we've sort of adjusted where this particular amount of detail is based on the ambient occlusion map so that it really shows up sort of more in the crevices and imagining some weathering occurring because there's nothing blocking the wind from going past this part of the pot. So looking at our height map information that we have here, I can tell that we're going to run into some problems, mainly because the height information is so heavily contrasted. So the drips are white, but the background is pure black. And so to even this out, I'm going to blend in a 50% gray to sort of keep everything in line. So I'm going to make a new blend. And I'm going to get a uniform color. And if I double click on this uniform color and switch it to grayscale, I've got this slider here. And to make it really easy, I can just type in 0.5 to make it 50% gray. So this blend I'm going to set to add. And I'm going to put the uniform color into the background and our current last blend here into the foreground. And then I'm going to connect this new blend into our final blend. And now not much is going to change, but I want to show you the difference here. So if I go into my materials in my 3D view and change this to tessellation, then I'm going to increase the tessellation factor to 16 and just bring up the scale by a bunch. In fact, I'm going to bring up the scale. Let's bring it up to 40. Now, you can see not much is happening. In fact, it's behaving the way we want it to. You can see that our drips here are gaining height and not much else is happening. However, if I didn't do this and I just connected my contrasted height map, you can see we're running into a lot of issues here, where because the height map has pure black information, that's actually decreasing and sinking in the height into our mesh. So if I now reconnect the new one with the 50% gray, everything brighter than 50% gray will extrude. And then anything that we add in, like this dirt that's darker, will dig into the mesh. And so now we have something a bit more realistic. And our mesh is still in one piece. Also, now that I look at it, with the ambient occlusion that we're generating, the height depth is looking a bit intense. So I'm going to go to our ambient occlusion conversion node. Not to be confused with the ambient occlusion map that we generated, but the one that here at the end that's connected to the main output node. I'm going to dial down this height depth. 0.03. I think that looks a bit better. So now I'm going to go back. Just keep things organized here. We've got our final blend. We've got our chain of blends here, bringing everything together. And then we also have our drips and dirt. So let's select these nodes here before the one that includes the uniform color. I'm going to frame those up and call it drips and dirt. And let's just bring this one out here. So now this is what our graph looks like so far. So what I want to do next is sort of blend everything together, because remember, we still have this edgeware height that we haven't included yet. So let's make a little bit more room. I'm going to take all of these outputs and our final blend, just bring this over. So we've got more space here, and let's add a blend. And so what I want to do is subtract this edgeware from the rim. So if I set our new blend that we just created to subtract, and then in the foreground, what we're subtracting is the result of this new edgeware, and severely take down the opacity. Let's look at what we're looking at here. That's the edgeware. So we're getting just a slight bit of detail around these edges. Now, what I also want to do is blend in this generated ambient occlusion with our ambient occlusion over here. So let's take these nodes and bring them down to this level here. Make a blend. Here's the height generated AO. Let's bring this into the foreground, and let's grab our baked mesh map ambient occlusion and put it into the background, and then set the blending mode to multiply. Then I'm going to reconnect this into the ambient occlusion output, which adds a bit more softness and ties our texture together. Finally, I also want to blend together the bent normals map that we created with the normal map that we have here. Now, to make this smooth and compute correctly, we can't just use a blend node. We have to use a normal blend node. So I'm going to click on the graph, hit spacebar, type in normal, and find the normal blend. I'm going to take the generated normal map from our height, put that in the background, and then to connect our bent normal map, I'm going to shift click where this input is on our normal output and connect it to the normal blend. And so nothing's happened, but if we double click the normal blend and look at this use mask checkbox, we're going to set this to false and then bring down the opacity. And I'm thinking a 50% blend is fine here. So I'm going to type in 0.5. Now both of these are blending together, and then we'll reconnect this normal blend into the normal output. So now we're getting that more detail, and that's where that subtraction is going to show up a bit more when we did the edge wear for the height. And we're seeing our textured pot come together. And so now we have our procedurally textured pot based on the baked maps that we have from this linked up geometry. We started off with our baked maps, and then we use that information like the curvature map to add this micro edge wear and this extra height-based edge wear, and even those thumb smudges that we added. We put that into places like the color and also our final blend, which goes into the height. We also added this drips and dirt texture on top of the pot. And once we created that information, we then used this histogram select to drive a mask that we could use to decide where we want those drips to occur. And then we integrated those drips and dirt using our ambient occlusion baked map and a histogram select and directional blur to then create a mask in which we blended it all together. We evened things out by blending in a 50% gray uniform color so that when we change our height and displacement, everything still settles together. And once everything's all blended in together into our final outputs, we get this. And what's cool about this is that this is all based on this particular mesh and its baked maps. So because we linked this geometry into the substance graph, if this changes, all we have to do is right click and choose refresh all baked map. It then rebakes these, and then all this procedural programming that we've done updates, gets affected, and adds our edge wear and information automatically. By linking the model with the graph, you expand a Substance Designer's capabilities. Baking out mesh maps gives you the information that you need to tailor specific processes to the specific geometry that you are working with. Now that you have this tool, you can link any model that is UV'd in a similar fashion. And this is just one example of how this technique can enhance your pipeline. If you like this video, hit the thumbs up. It lets me know that you like this specific kind of video. And if you want to see more texturing and Substance Designer videos, hit subscribe and hit the bell to be notified when I post more. I'm Jeremy Seiner, and I'll see you in the next one.